This classic illustration of Alice in Wonderland captures a long-standing pop culture fantasy. We love the idea of shrinking down to explore hidden, microscopic worlds. But activating a real-world shrink ray wouldn't turn you into an intrepid explorer. It would trigger immediate biological failure. Visible light travels in waves with a fixed physical size. If your eyes shrank to the size of a pinhead, these wavelengths would be physically too large to enter your miniaturized pupils. You would be completely blind. At the same time, your vocal cords would contract to a fraction of a millimeter. Any sound you tried to make would vibrate at such an extremely high pitch that it would fall completely outside the range of human hearing. You'd be rendered completely silent, stumbling in absolute darkness. And surviving those bodily failures is just the first, relatively minor barrier before you run into the unforgiving laws of physics. Let's assume you shrink in physical volume, but your mass stays exactly the same. Your physical density reaches an extreme, lethal level. See this ant resting on a branch? In the movies, a shrunken hero might saddle up and ride it. Concentrating all your human mass into an area the size of a speck of dust means you would instantly crush the insect beneath you. Even if your biology magically adapted, your localized, super dense wheat makes you a walking hazard to the microscopic environment. But the true, insurmountable problem is hidden deeper inside you, at the atomic level. The human body, like all matter, is built out of atoms. These microscopic building blocks dictate exactly how much physical space you occupy. This diagram shows the structure of an atom. Notice the electron's orbital path creating a fixed, rigid boundary around the center. The size of that boundary is locked in by absolute mathematical rules, like the fundamental charge of an electron. You cannot tweak those rules to make the atom smaller without breaking physics entirely. Still looking at this atom, you'll see a massive amount of empty space between the tiny nucleus in the center and the outer electron boundary. Science fiction often uses this as a loophole, suggesting a machine could simply squeeze that empty space out. The atoms making up the molecules in your body are already packed incredibly tight. Forcing them to sit any closer together requires unimaginable amounts of pressure. If you applied that pressure to a person, it would bypass shrinking entirely and result in a grotesque bodily collapse. Trying to manipulate the space inside an atom isn't a medical procedure. It is a direct assault on the mechanics of the universe, and it ends in an explosive reaction. Let's escalate the scenario. Assume your shrink machine works, applying enough pressure to force your atomic nuclei to physically touch. When atomic nuclei are smashed together under immense, overwhelming pressure, they merge to form new elements. This specific scientific phenomenon is called nuclear fusion. Look at the sun. Nuclear fusion is the exact process releasing enough energy to power it and every other star in our solar system. Applying that level of compression to the atoms in your body would cause you to instantly detonate with the radioactive energy of a star. Defying the physical boundaries of the atom does not leave you as a tiny, highly capable person. It triggers a catastrophic nuclear explosion right where you stand. Let's push this thought experiment to its absolute limit. Imagine you survive the nuclear detonation, and your shrink ray continues to compress your mass into a smaller and smaller space. To understand what happens next, look at this photograph of the moon. If you compressed a celestial body of this mass, its density multiplies exponentially. As this animation illustrates, packing enough mass into an infinitely small area eventually creates an object so dense that its gravitational pull prevents anything, even light, from escaping. You have created a black hole. The ultimate endpoint of a shrink ray is the total annihilation of your surrounding environment. While biological beings cannot survive miniaturization, human beings actually did master the physics of shrinking in one specific area: electronics. This photograph shows a computer room in the 1950s. Early processing panels were massive, taking up entire rooms just to perform basic calculations. Now look at this replica of the first transistor. These tiny electrical switches allowed engineers to start dramatically reducing the size of computing hardware. Using the strict rules of quantum physics, scientists figured out how to manufacture these components down to the size of a single virus. Today, billions of them are actively routing complex information inside the phone or computer you are using right now. The absolute laws of physics forbid us from packing a human body into a microscopic space, but respecting and understanding those very same physical rules allowed us to shrink our technology and build the modern world.